Hello everyone, and welcome. This is lesson 5 of our ICAP capstone project. We're talking software architecture to vibe coding.
Vibe coding, I love that already, Sasha.
Absolutely. Today, we're diving into hybrid architectures. Specifically, a mashup of Flask and Anvil. This session is brought to you by ICAP Technologies.
Flask and Anvil together? That sounds really powerful.
It truly is, Marina. On this slide, we're looking at how to integrate them. We want to embed an Anvil application with a Flask screen.
So Anvil is kind of the wrapper?
Exactly. The goal is to create a home form in Anvil. This form then calls a custom HTML form. And that's where our Flask application lives.
Ah, like embedding a video, but it's a whole app.
Precisely. You can see the Anvil designer interface on the left. It shows Show Projects and Search Projects buttons.
Yes, I see them. They look clean.
On the right, we have the Anvil Python code for the home form. It defines methods like Show Projects link click. When Show Projects is clicked, it adds a project's iframe component.
So that's how it pulls in the Flask app?
You got it. It's designed to embed the Flask application seamlessly.
That's super clever. What changes do we need for Flask itself?
Fantastic question, Marina. To make our Flask application embeddable, we need a few tweaks. Both its template and its main application file.
Okay, so 2 places.
Exactly. On the left, you see changes in the Flask HTML template. We're adding a context variable called embed. If this variable is true, we avoid showing the banner and navigation bar.
Ah, so it's a conditional display for embedding. Smart.
Yes, it cleans up the embedded view. On the right, in flaskapp.py, we've initialized a Flask app and applied CORS.
CORS for cross-origin requests, right?
Spot on. That's crucial for embedding across different origins. We've added an additional root, embed, for this purpose. If called via this URL, the embed variable is passed as true.
And the template knows what to do then.
Precisely. Most importantly, we added an after request handler. This sets the X-frame options header to allow all.
That's to make sure it can be displayed in an iframe, isn't it?
Absolutely, Marina. Without it, browser would block the embedding. Now, let's see the Anvil application with the Flask screen in action.
Oh, this is exciting.
The top bar shows the Anvil application's URL. Below that, within the Anvil interface, our Flask application is successfully embedded.
Wow! It really looks seamless, like it's all one application.
That's the goal. It displays a dashboard of various projects, like software architecture to vibe coding, AI architecture, and more.
I see descriptions, status, requirements. It's fully functional.
Yes, each project has edit and delete buttons too. It really demonstrates the full power of the embedded Flask app.
This is amazing. It truly looks integrated.
Now, let's explore how we enable searching projects using AI. Specifically, a large language model.
Oh, an LLM, that's cutting edge.
Indeed. This slide shows the Anvil client-side code for search projects. On the left, the Anvil UI for searching. A user can enter a job or role description.
So, like I'm looking for a machine learning role.
Exactly. On the right, the Anvil Python code. We define the send button click event. When clicked, it retrieves the user's query text. Then calls a server function, search projects chat, via anvil.server.call.
So it sends the query to a backend function?
Yes, and the response from the server, with AI recommendations, is displayed in the response-rich text component.
That's super clear how the user interacts with the AI.
This slide focuses on the server-side Anvil uplink code for the AI-powered project search.
Okay, the brain behind the search.
Precisely. We define a callable server function, search projects chat. It takes the user's query as input. Inside, it retrieves all project descriptions from our Anvil database.
So it gets all the project info first.
Yes. Then, it constructs a prompt for the large language model, including clear instructions to evaluate the projects, and list the 2 most relevant ones, based on the user's query.
That's fascinating. A custom prompt for the LLM.
This content is then passed to the Call Gemini function, which interacts with the Google Gemini LLM API.
Gemini, that's a powerful one.
Absolutely. The LLM's reply is then returned to the client side. And as a note, this can run locally or be deployed to Vercel. Just remember, annual uplink in your requirements.txt.
That's super helpful. I'm really keen to see it in action.
Here it is. The search projects using AI, LLM, in action. A user entered, machine learning research scientist.
A very specific query.
Yes. After clicking, send the application, powered by AI, response. It gives recommended projects to help prepare.
Wow, it pulled AI architecture fundamentals and advanced software architecture.
Precisely. The AI identified them as most relevant and provided explanations for each.
That's incredible. It understands the context perfectly.
It truly demonstrates the powerful capability of integrating an LLM into our annual application.
This opens up so many possibilities.
Absolutely, Marina. Now, let's look at the overall system architecture. Flask in Anvil, combined with AI.
The full picture.
At the center is the browser, where the user interacts. The Anvil web server serves Python and HTML, JS code. The Flask web server also serves HTML, CSS, JS.
So both are serving content to the browser.
That's right. The Flask application server handles the Flask logic and interacts with a NoSQL database for project data. The browser embeds the Flask application via an iframe, with communication happening over HTTP.
That's where the CORS and XFrame options come in.
Precisely. For the AI search functionality, the Anvil application server makes REST API calls to the Google Gemini LLM API.
And what about the project data for the AI search?
Great question. Data from the Anvil Postgres database is queried and updated via the Anvil application server. Finally, the browser can also communicate directly with the Anvil application server using Anvil uplink over WebSockets for real-time interactions.
Wow. So many layers of communication working together.
It truly is a hybrid and integrated system. In summary, what have we achieved today?
So much.
We've created an Anvil application with two main screens: Show Projects and Search Projects.
The Flask dashboard inside Anvil was so cool.
Yes, Show Projects effectively opens our Flask-based dashboard within an iframe, which required specific changes in the Flask application to ensure proper embedding.
And the AI search, that was the real game changer.
Absolutely. The Search Projects feature enables an AI-based search using the Gemini large language model, allowing users to find relevant projects based on a job or role.
That's incredibly powerful and practical.
This was accomplished by implementing a server function. It intelligently prompts the large language model using project descriptions from our Anvil database, combined with the user's query.
What a fantastic session, Sasha. I learned so much.
That's wonderful to hear, Marina. Next, we will delve deeper into technical architecture concepts, especially non-functional components and how to make architecture decisions in real life.
I can't wait for the next lesson.